Good afternoon and welcome to the National Science Foundation. I'm Lily Whiteman. Today we are very fortunate to have with us Dr. Timothy Herbert, who's a professor and chair of the Department of Geological Sciences at Brown University. On June 18, 2010, Dr. Herbert and his colleagues published an important paper in Science entitled Tropical Ocean Temperatures Over the Past 3.5 Million Years. Today we're going to discuss with Dr. Herbert his findings and the implications of those findings for climate change. So Dr. Herbert, thank you for being with us. What are the most important findings from your study?
Well, we created the first tropical wide record of ocean surface temperature changes over the last 3.5 million years. That's the time in which the Earth first went into these great ice ages that continue right up to the very recent past. And what we found that really surprised us is that the tropics seem to shiver when the polar latitudes get cold and they warm up when the ice ages pass. Now, we know that the story of the ice ages started about 2.7 million years ago. And since then, there have been about 45 separate ice ages. And what we found was that during each of these ice ages, all over the tropical oceans, temperatures cooled during ice ages, and then they warmed up when the ice ages passed.
It's incredible to me that water temperatures in the northern latitudes would affect the tropics, which are thousands of miles apart. Is this the way that it works?
Well, we think the best explanation that would connect these changes so far away from each other is for a dominant role for carbon dioxide in the Earth's atmosphere to help to coordinate changes between different parts of the climate system. And that's the best explanation for why we see these patterns in the tropics that are so similar to what we already know is happening at the high latitudes.
If CO2 has had this effect in the past, what does this say about ongoing warming and rising CO2 levels now?
Well, the fact that we found what looks like a really predictable pattern of warming and cooling all over the tropics that's best explained by changes in CO2, that would suggest that that's the future we can look at too, that carbon dioxide changes will have an effect that's felt clear across the tropics and produce rising temperatures.
Dr. Herbert, just why are changes in tropical temperatures important? Why should we care? Why do we need to understand what's going on in tropical waters?
The tropics are really, really important to global climate. One thing that's really important to know is that essentially all of the water vapor in the atmosphere, what comes as rain over the ocean or on land, it starts off as water in the warm tropical ocean that evaporates. So the reason it's there is we have a warm tropical ocean. And the evaporation of water into the atmosphere, which fuels rainfall, depends directly on the surface ocean temperature. So if the temperature in the ocean in the tropics changes, the amount of water going into the atmosphere changes very directly. There's a second big reason besides how it would affect rainfall and climate rainfall, and that's the water vapor feedback on global temperatures. So water vapor is actually the single most important greenhouse gas in the Earth's atmosphere, and the amount of water vapor in the atmosphere depends directly on ocean temperatures, particularly the tropical ocean where most water evaporates, so that if you begin a climate change and cause the tropical oceans to warm up or cool down, you crank up this water vapor feedback, which makes any climate change a lot bigger than it would have been, what we call a positive feedback.
How did you track temperatures so back in time?
What we do in my lab is we take the remains of tiny microscopic marine plankton. They live in the surface ocean. They die, fall down to the bottom, become covered in layers and layers of sediment. What we do is take these ocean cores back to the lab. In our case, we took actually many thousands of samples to put this study together. And we do chemical analyses. We actually extract molecules from the remains of these organisms that lived in the surface, used sunlight back at the time they lived. And we use chemical clues in the molecules that tell us about the temperature of the water back at the time they lived and died.
So the consensus among scientists is that people are causing the ongoing rise of CO2 levels. So your study goes way before people were around. What would be causing these changing CO2 levels?
Well, that's something of a mystery. We really don't know. We do know that on the timescales we're talking about, of thousands to hundreds of thousands of years, the ocean is really the big player in the Earth's carbon cycle on those timescales. So in ways we still don't understand, the ocean is connected with changes in the Earth's carbon cycle that then really dictate global temperatures, not only ice, but also temperatures as far away as the tropics.
Well, I know that every answer to a scientific question creates more questions, so what are the questions you'll be working on in the future?
Well, absolutely. We have surprising findings that we don't completely understand. The things that really fascinate me would be trying to understand why this CO2 feedback and the strength of climate changes increases toward today, as if the system, it's like those movies of the bridge that starts shaking and then shakes more and more wildly as time goes on. And that's what we see in the Earth's climate, that as we come toward today, the strength of the ice age cycles and the CO2 effects become bigger and bigger. And we don't understand why that's changed over time.
Is there anything else about your important study that you would like the public to know about?
The message seems to be that global climate's incredibly interrelated, that when you change things in one place, you produce large changes in another place that you might not have expected. And these changes seem to add up to make the overall changes stronger or bigger than you might have thought when you started. I think the sort of sobering thing is to try to realize that we don't understand all these feedbacks and linkages. We don't fully understand how, if through human activity we affect part of the globe, how those are going to cascade or show up in other parts of the system. I'd say from our study, we can say that the areas that don't directly feel climate change will sooner or later almost certainly feel a very strong change. I think that's what this tropical data is shouting out to us, in how similarly it's marching or it's dancing to the speed that's ultimately happening at very high latitudes with the ice ages.
Thank you so much, Dr. Herbert.
Thank you, Lily.